Okay, everyone, Assalamu alaikum. Let's begin. So in the last session, we completed circle equations. And today we want to start our next topic, which is AP and GP. That's the last topic that we have in paper one. Now, I understand that you still might have questions from the circle equations worksheet. You can let me know what problems you still have. We will discuss them right after the Eid break, inshallah. So today, what I want to do is I want to cover the last topic in terms of concepts, at least, so that you have all the concepts covered in the syllabus, and then you can use this Eid break to do some more practice. And if you have any problems on both of these topics, equation of circle or AP and GP, we could have a couple of classes after the break in which we would discuss those problems. Okay. So that's why I want to cover AP and GP in today's class. Now, those of you who have attempted the questions from the worksheets already, can you tell me if you have any problems from the circle equation worksheet? Do you guys have any problems? Or were you able to do all of them, all the questions? So there were 5 questions in particular that I think I asked you to do in the last class. Were you able to do all of them? Okay, so question number 16. That's one question that I'm getting. Okay. What about the rest of you? So I've only heard from Hazem until now. What about the rest of you? Any problems from the worksheet, from the circle equation worksheet? $19. Okay, all right. So what we're gonna do is we will have another class or a couple of classes right after the Eid break. So those of you who haven't attempted the questions yet, please make sure to attempt those questions as well. And then we will do more practice on both the topics when we come back from the break, inshallah. Okay. But for today, let's discuss the AP and GP concepts. Let's start with this. Let's start with arithmetic progressions. So AP and GP, this basically stands for, okay, all right, Hazan, that's okay. So both of you are basically asking about question number 19. So we will discuss that when we come back from the break then, all right? Along with any other questions that anyone else has, we will spend a couple of more classes on some more practice then, inshallah. Arithmetic and geometric progressions, that's our next topic. Let's start with arithmetic progressions first of all. It's also called AP. Now, first of all, let's try to understand what a progression is. So you've done a topic called sequences in O-levels, right? You should remember that from O-levels, sequences. So progression is basically just another name for sequence, all right? So this topic is basically related to sequences. So progression is just another name for sequence, okay? There's another name that you will see being used sometimes as well. That's called series, although the exact mathematical meaning of series is slightly different from sequence or progression, which you will, the distinction between them you will understand when you do your first university course later on. But for now, for our purposes, they are going to mean the same thing. So you might, somebody might be calling this an arithmetic progression, arithmetic sequence, arithmetic series. All of these terminologies for our purposes, they're going to mean the same thing. It's a sequence of numbers that follows some pattern, okay? Now let's start with arithmetic progression, first of all. Arithmetic progression. Now, what are arithmetic progressions? Let me write down a sequence of numbers here that looks like this. So let's say we have 6, 10, 14, 18, 22, 26, and so on. So we have this sequence of numbers written like this. Now, can you figure out what the connection between these numbers is? So if you were to look at these numbers and tell me what the next number should be, what do you think the next number should be? Following the same pattern?
30.
It should be 30, right? So how do you figure that out? You look at the pattern and see, okay, how are you getting the next number in the sequence? Basically, what's happening is to the last number, you're just adding 4, right? In order to get the next term, you're just adding 4 to the previous term. Or in other words, we can say the difference between the consecutive terms, that is constant. Okay, so you can see the difference between any two consecutive terms, that's constant. This is what an arithmetic progression looks like. This is what an arithmetic progression looks like. It's a sequence in which the difference between consecutive terms is constant. The difference has to be constant. Okay. Now, an arithmetic progression is basically described by two things. So in order to describe an arithmetic progression, we need two things. Now, let me write them down here. Number one is the first term of the sequence. So you basically tell, okay, this is where the sequence starts from. This is the first term. So in this case, for instance, 6 is the first term. All right. Now there's a notation that we will be using for first term. We will be calling the first term A. All right. So we will denote the first term using the letter A mostly. Then the second thing that you need to describe an arithmetic progression is the difference between the terms. It's also known as the common difference. The common difference, what that means is the difference between consecutive terms, and this is denoted by this letter D. Okay. So first term is obvious. In this case, the first term is 6. The value of A would be 6. How do you find the difference? You take any two consecutive terms in this sequence, any two consecutive terms. You can take, for instance, 1822. You can take 1014. You can take 1418. Any two consecutive terms. If you had to find the difference of an arithmetic progression, all you have to do is difference is equal to the next term minus the previous term. Next term minus the previous term. So for any two terms, the term that's coming after, you subtract from that, that's coming before. So in this case, for instance, you would do 22 minus 18, and that's going to give you the difference, which in this case turns out to be 4. Okay, so in this case, you would say the value of A is equal to 6, and the value of difference, take any two consecutive terms, you could say 10 minus 6, the difference is 4. These are the values of A and B in this case. All right. Now, what we need to be able to do is we need to be able to write down any specific term of a sequence. So for example, if a sequence looks like this, if I were to ask you what's the 10th term of the sequence, so we denote by this notation T10. What's the 10th term of the sequence? How could you figure that out? You've looked at the pattern and you see, okay, in order to get the next term, you can just add 4 to the previous term. Now, this is the first term, second, third, fourth, fifth, sixth. You've got 6 terms already. If you had to find the 10th term, you would say the next is going to be 30, and then you have 34, and then you have 38, and then you have 42. So the 10th term, therefore, is going to be 42. All right, so this is what the term that comes in the 10th position. Okay, but if I were to ask you what's the 100th term, that would take quite long, right? If I were to keep writing the next term like this, and I'd have to go all the way up to the 100th term to figure out what that 100th term is. In order to avoid all of that work, we basically come up with a formula, a general formula that we can use to find any specific term of a sequence. So if I were to look for the 100th term, for instance, how could I find that 100th term directly? There's a formula that we have for this. And that is something that we call the term formula. Term formula of a progression. Now, let me write that down here. Term formula for an arithmetic progression. Let's see what that looks like. What the term formula is supposed to do is it's supposed to give you a specific term in the sequence. This is what the formula looks like. It says Tn, that is equal to A plus N minus 1 times D. So if you're looking for any specific term in an arithmetic progression, this is the formula that you can use for that. Okay. Now, what do these notations represent? A is the first term. D is the difference in that sequence. N is the position of the term that you're looking for. And what about Tn? Tn basically means nth term, which means it's the value of the nth term, basically. It's the value of nth term. So basically, in this case, for instance, when we said the 10th term is 42, we would say T10 is equal to 42. This is the value of the 7th term, right? That's what the formula looks like, the nth term formula. So now if we were looking for a specific term in a sequence, let me take that same sequence as before. This was the sequence that we had. Let me just copy that here. If we were to find a specific term in this sequence, how could we do that? Let's try this. So we know that the first term of the sequence is 6 and the difference of the sequence is 4. If we were looking for T40, for instance, how would you find that? You just input values in the formula. A plus N minus 1 times D. Okay. What's A? A is 6 plus N. What's the value of N? The value of N is 40 here because we're looking for the 40th term. Right? So we have N minus 1. That means 40 minus 1 times the difference. The difference is 4. Just input values in this formula, and that's going to give you the value of this 4th term. Make sense? You can see what this turns out to be now. 6 plus 39 into 4, and that's giving me 162. The value of the 40th term in this sequence is 162. Okay, so that's how the term formula is used in an arithmetic progression. Okay, now we often will be denoting it by Tn, but in the formula sheet they use Un instead of this. So don't get confused by that. Un, so they use this notation instead of Tn. For the nth term, they use Un. So that also means the same thing. In the formula sheet, it will be written like this, and that's perfectly okay. You can write it as Tn or Un. Both of them mean the same thing. It's just a different notation. Okay? So that's what the nth term formula looks like. Is that okay? Now, let's take another example of this. Let's say we want to find the common difference between consecutive terms of an arithmetic progression. That starts from 3 and its 20th term is 193. So you can have something like this, that you have the nth term given. So in this case, the 20th term is given, and you have to find the value of the difference. You could have the first term missing sometimes. In this case, you've got the difference missing. How do you find the value of that difference You use the term, the nth term formula. What does that look like? Tn equals a plus n minus 1 times d. Now, what's the information that's given in the question? They've basically told us that it's an arithmetic progression, right? So they have told us it's an arithmetic progression. So it's an AP. The value of a, the first term, that is 3. And then 20th term, that means T20. That's what 20th term means. T20 equals 193. This is the information that we're given in the question. And what we're looking for is the value of D. We can just input this information in this formula, T20. So if you want T20, what would that look like? A, that's 3, plus N, that's 20 minus 1 times the difference. This is what the 20th term is supposed to be. They have told us that the 20th term is equal to 193. So we equate this to 193. We say 193 should equal 3 plus 19 times D. And that gives you 19D equal to 190. And the value of D turns out to be 190 over 19, which is 10. That's the difference between consecutive terms of an arithmetic progression. Okay, so that's how you use this term formula. I hope that makes sense. Any questions on this? Any problems, anyone?
Sir, can you repeat it again?
Exactly what part?
Sir, the nth term is 20.
Nth term is not 20. 20th term is 193. What that means is when n equals 20, T20, that's 193. That's what the question says. 20th term is 193. So all we have to do is, in place of n, input 20 in the formula. So that's what we've done here. In place of n, we have put 20. And what's the value of the nth term? Tn represents the value of the nth term, right? What the number is on that position. Instead of T20, therefore, we input 193. That's all that we do. When n is equal to 20, the value of that term is 193. So we're just inputting values in the formula.
Okay, sir.
Okay. So that's how we use nth term formula of an arithmetic progression. Now, this is something that you've actually done in paper, not in paper one. In fact, you're doing paper one right now. You've done this in O levels as well. I'm sorry, in O level maths as well. You've done arithmetic progressions. Although in O levels you used to call it a linear sequence. So you used to have a linear sequence, quadratic sequence. The linear sequence that you did in O levels, arithmetic progression is the formal name of that sequence. We call this an arithmetic sequence, arithmetic progression. So I think most of you have done this formula before as well, a plus n minus 1 into d. We teach this in O levels as well. But now, let's have a look at another sequence. Let's say we have a sequence that looks like this now. We have some numbers. It's an arithmetic progression again. So we're given it's an AP. And the numbers in the sequence look like this: 5, 8, 11, 14, 17, and so on. These are the numbers that we have in the sequence. Okay. It's an arithmetic progression. Now, what's the first term? What's the value of a in this? The value of a is going to be 5. What's the value of the difference? Difference is going to be 8 minus 5. So we can say the difference is 3. All right, that's the value of the difference. Now, by the way, before we actually do this, let me give you another example quickly, so you understand the difference does not always have to be positive. If I had a sequence like this instead, maybe an arithmetic progression that looks like this. Let's say 90, 86, or 81, 72, 63, 54, and so on. What's the first term of the sequence? The first term is 90. What's the difference? What would the difference be in this case?
81 minus 90.
81 minus 90. So don't just look at the progression and see, okay, the difference is 9. Remember, for arithmetic, for finding the difference, you basically have to subtract the previous term from the next term. Next minus previous. So any two consecutive terms that you take, if you take these two consecutive terms, the difference would be 81 minus 90. Since the values are reducing, the difference is going to be negative in this case. So the difference can also be negative. Keep that in mind. Okay. So in this case, the difference would be negative. So you have to subtract the previous term from the next term. This is how it's going to work. So difference can also be negative. Keep that in mind. Okay, now let's get back to this example. So we had this sequence 5, 8, 11, 14, 17, and so on. A is equal to 5 in this sequence, and the difference is equal to 3. Now there's another terminology that we use here, and that's called SN. So this notation that we use here, SN. What does this mean? SN basically stands for sum of the first n terms in a sequence. The sum of the first n terms. Now, let me explain what that means. So for instance, in this case, S3. What would that mean? That would mean sum of the first 3 terms. All right. How do you calculate that? 5 plus 8 plus 11. And that's going to give us 24. Right? So that's what this notation stands for. If you had to calculate S3, that will be 5 plus 8 plus 11. Similarly, if you had to calculate, for instance, S1, what would that be? That's just the first term, right? That's 5. If you had to calculate S2, what would that be? 5 plus 8. And that gives us 13. If you had to calculate S4, we just add the first 4 terms, 5 plus 8 plus 11 plus 14. What does that give us? That gives us 38, and so on. That's what this notation means. SN stands for sum of the first n terms of a sequence. But now, here we were just looking for the sum of the first few terms, and we already knew what those terms were. But what if we wanted sum of the first 30 terms? What about that now? What if you wanted sum of the first 300 terms? What about that? Now, that will require us to add a lot of numbers, and that manual working is going to take a lot of time. So we need some direct method for evaluating this sum as well. Okay, just like we have a term formula, a plus n minus 1 into d, it's given in the formula sheet. We need some formula for the sum as well. So basically, sum of an arithmetic progression, that's given by this. Sum of an AP, that's Sn equals half n multiplied by 2 times a plus n minus 1 times the difference. This is the sum formula for an arithmetic progression. Sn stands for this. Okay. Now, again, this is given in the formula sheet. We can briefly try to have a look at where this comes from. It's not required as such in your syllabus. You will be given this formula in the formula sheet. You just need to be able to use it. Now, for instance, if you were looking for S30, like in this case, we wanted S30. What's the first term? The first term is 5 and the difference is 3. Let's just input those values here. In this case, the first term was 5 and the difference was 3. If we wanted S30, what does S30 mean? S30 means sum of the first 30 terms. Let's just input values in that. 1 over 2 into n. What's the value of n? Instead of n, we've got 30. So we have 30 here. Multiplied by 2 into a. What's a? A is 5. So we have 2 into 5 plus n, which is 30, minus 1 times the difference. What's the difference? Difference is 3. That is what you end up getting. Okay, now 30 over 2, that's 15. You can just put this whole thing on your calculator now. This gets cancelled. Let's see what the calculator gives. 15 multiplied by 10 plus 29 into 3. And that's giving me 1455. So sum of the first 30 terms of the sequence, that equals 1455. That's how we use the sum formula. Okay. Any problem with this?
No, sir.
No. Now this is one formula that we can use for sum of the first n terms. We actually have another formula as well, and that's also given in the formula sheet, and that looks like this. So there's another formula that says Sn equals half into n into a plus L. This is another formula that's given in the formula sheet. Okay, this is another formula given in the formula sheet. Now, how do you use this formula? We know what n means. N is the position of the nth term, right? So if we were looking for S30, for instance, we know the value of n is supposed to be 30. A is again the first term. What about L? L stands for last term in this case. But if you have a sequence like this, the same sequence as before, if you have this arithmetic progression, and you had to use this sum formula on this arithmetic progression, what would be the value of L in this case? What's the last term? Is there any last term of the sequence? The sequence is just continuing like this, right? It's never ending. So there's no last term of the sequence as such. So
Sir?
what exactly? Yes.
Sir, can't we say it's L plus 3? Like 3 terms
L
are
plus
added for L.
L plus 3. I don't understand what you mean by that. L plus 3.
Sir,
What would
as
that
3
mean?
terms are added in the sequence, so can't we replace L with L plus 3?
How are 3 terms added in the sequence?
Sir, 5, 8, 11, 14, and 17.
That's 5 terms. What do you mean 3 terms are added?
Sir, no, I mean 3 is added into the sequence.
So 3 is the difference. 3 is the value of the difference. How does that relate
Okay,
to
sir.
the last term? That doesn't have anything to do with the last term here as such. Okay, let me actually get back to this. Let's try to understand this first. So 5, 8, 11, 14, 17. This is what the sequence looks like. It's a never-ending sequence. Okay. Now it goes on like this. What does L here mean in this formula? Because you can see there's no last term of the sequence as such. Now there's a particular meaning of this of this letter L here. Last term here basically means Tn, the nth term. That's what it actually means. Now let me explain how you would actually use that. The letter L here, so L comes from last term, but there's a specific meaning for that. It means the nth term. Now, how are we going to use this? If we were looking, for instance, for S4, if we were looking for sum of the first 4 terms, let's say, okay, sum of the first 4 terms, how would we use this formula? We would say it's half into n, which is 4, into a. What's the first term? The first term is 5, plus L. Now, last term here basically means among the 4 terms that we have to add, out of these 4 terms, what is the last term? So these are the 4 terms that you want added. In these four terms, what's the last term? In these four terms, the last term is 14. So instead of L here, you will be writing 14. So that's why we can actually say L is basically Tn. That means if n is 4, L means it's T4. Fourth term, that's 14. So L is basically the term that is coming in the last position amongst the terms that you have to add together. That's the specific meaning of this last term. Now, if you had to calculate this value using this formula, let's see what that turns out to be. It's 2 into 19, and that's 38. And that's exactly the value that we calculated here manually as well, 38. So this could be another formula that you could use for finding sum of the first n terms of an AP. So now that we understand what L means here, another way to write the same formula could be like this. We could say Sn equals half n into a plus t times n. So in the formula sheet, you will have L written. L basically stands for Tn here, right? That's what L essentially stands for. So if you want, you can replace it with Tn here, and that will help you understand this better. And now you can see if it is Tn, these two formulas are actually the same in a way. So this formula that we have here on the right side, it's the same as that earlier formula. How? Because what's Tn? Tn is a plus n minus 1 times d. So you could try that, half n into a plus. Tn is a plus n minus 1 times d. And that gives you half n into 2a plus n minus 1 times d. And that's exactly what we've got here as well. Right? So these are essentially the same formulas, just two different ways of writing this. Okay? So how do we know which one of the two formulas we should be using? Well, you can look at what are the inputs to these formulas, and you just see, okay, what formula will help us get to the result directly, because sometimes you will have the first term known and the difference known. In that case, you will use the first formula. And that's most of the cases. So 90% of the times you will be using the first formula. Okay. Sometimes using the second formula is going to be slightly more efficient. And that is when you do not have the difference given, you know the first term and you know the nth term or the last term. If that is already given, if the last term is already given, in that case, using the second formula will be more efficient. Now, in this case as well, if you wanted, you could use these two things to find d first and then use the first formula again. And that's perfectly okay. So the first formula will work for every single case. However, using the second formula is going to be slightly more efficient when you know the last term of the sequence. So you can use both of them. Both of them are given in the formula sheet and they're written like this. I'm going to write this here. In the formula sheet, it basically says this Sn equals. So when you look at the formula sheet, it'll show you something like this. Sn equals half n into 2 times a plus n minus 1 times d. This is one sum formula. And you have another one, which is half n into a plus l. And now you understand that L basically stands for Tn. L is essentially the same as Tn. Okay. These are the two sum formulas that we've got. Sn means sum of the first n terms. And the second formula is only used when you already know the last term. Okay. Otherwise, you always use the first one. So use this formula only when you have the last term given. Last term means Tn basically, the nth term. Otherwise, in most cases, you will be using the first formula And that is something that's going to always work. Is that okay to everyone? Any questions on this now? Any problems, anyone? No?
No, sir.
So we have a term formula for AP. The term formula looks like this. Tn equals a plus n minus 1 into d. We have two sum formulas for AP. These are the two sum formulas. And we discussed when you should use which one. Okay? All right, let's move on. Now, sometimes they ask you something like this. So let's say you have a sequence that looks like this. 105. 105, 112, 119, 126, 133, and so on. You have this arithmetic progression. And now what you want to do is, you want to find the sum of all the terms in the sequence between the 9th term, or let's say the 10th term, and let's say the 35th term, both inclusive. That means 10th term should also be included, and the 35th term should also be included. Find the sum of all the terms between the 10th term and the 35th term of the sequence. This is what you want to find out. Does that make sense? So you have a sequence. This is what the sequence looks like. It's an arithmetic progression. Can we write down the first term? The first term is 105. So A equals 105. What about the difference? 112 minus 105. The difference turns out to be 7. So these are the values of A and D. Now, using these values of A and D, what you want to do is you want to find the sum of all the terms in the sequence between the 10th term and the 35th term. Is that okay? Now, how do you find this? How do you find all of these terms? Now, let's think about this. So remember what we're looking for? Sum of the terms between 10th and 35th. What does the sum formula give us? Sn. What does this formula give you? This gives you sum of the first n term. So it has to start from the first term if you had to use this formula, right? Now, in this case, it says from 10th to 35th, can we just subtract 35 from 10? And that gives us 25. Is S25 going to give us the result? Is that going to work?
Sir,
You want the
we
sum
would
between
have
10th to
to,
20? Yeah. What's the
sir,
problem with this?
sir, it wouldn't include all the terms, I think.
What would be the problem with this?
It would include term 1 to 25.
It will include the terms from 1 to 25. It will add the terms from the first term to the 25th term. That's not what we want. We want from the 10th term to the 35th term. This is what we want. We don't want this. So we can't do S25. That is not going to work. This is not going to work. Okay. So what do we do then? How do we actually find the terms that we're looking for?
Sir, can we do S35 minus S10?
S35 minus S10, will that work? Okay, so what you're saying is we could do something like this. If we want the sum of all the terms from the 10th term to the 35th term, could we just do this? Find the sum of the first 35 terms, subtract from that the sum of the first 10 terms, and that's going to give us the sum from the 10th to the 35th term. Is that going to work?
Yes, sir.
Yes? Does everyone agree to this? There's a slight problem with this. Anyone who can spot that? Can this work or not? Okay, think about it. Let's say we've got the terms written like this. We have the first term, then we have the second term, and we have the third term, and so on. So what are the important terms? Then 10th, so let's write this, 9th, 10th, 11th, and then at some point we would have 34th, 35th, etc. Right? So this is what the terms are. These are the terms that we are focusing on from term 1 to term 20 to term 35. Okay. So what you're doing is you're saying, let's add all of these terms, sum from 1 to 35. That's what this is. What are we actually looking for? We are looking for the sum of the terms from 10 to 35. These are the terms that we want. So which terms should we subtract from the total? We should be subtracting these terms from the total. Up to what point? Up to the 9th term. So sum of all the terms from 10 to 35, this is actually going to be sum of the first 35 terms minus sum of the first 9 terms, because remember the 10th term also has to be included. Okay, 10th term also has to be included in the result. So it's going to be S35 minus S9 like this. Does that make sense?
Yes, sir.
So it will not be S35 minus now. If you have to find sum between two values, this is the term that in that window of 2.5. Okay, I'm sorry I got disconnected. I'm just sharing the screen again. Just give me a second. Okay, can you hear me again and also see the screen now?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, thank you. Okay, thank you. Okay, so we understood that we would subtract from the 35th term, from some of the first 35 terms, the sum of the first 9 terms, and that's going to give us the result. So that's what we do here. Just input values and see what that gives you. Half into 35 into 2 times A. A is 105, so 2 into 105. Plus n minus 1, that means 34 times the difference. Difference is 7. That's going to give us the sum of the first 35 terms. You subtract from that the sum of the first 9 terms, and that gives you half into 9 into 2 times 105 plus n minus 1, that means 10 minus 1, which is, 9 minus 1, that's 8 times the difference, that's 7. And that is going to give you the result. You can see whatever that turns out to be. You can do that calculation. All right, so this is how you would find the sum of terms between two values. Is that okay?
Sir,
Yes.
sir, where did 105 come from?
It's the first term.
Okay.
All right, so you can do this calculation and that will give you the result. Now let's have a look at another way of doing this. This could be one possibility. Another possibility could be that you treat it as a new sequence, in the sense that you start from the 10th term now. So you could start from the 10th term. So since you want the sum from the 10th term to the 35th term, you could first find T10. You could find the 10th term. You can see whatever that turns out to be. A plus n minus 1 into D, A105 plus n minus 1, which is 10 minus 1, that's 9 times the difference. You'll get the 10th term. And then you treat the 10th term as the first term of this sequence. The yellow part, you could just treat this yellow part as a new sequence. And you would say that, okay, this is the first term that I'm starting from, and then find sum of 26 terms of that sequence from 10 to 35. That will be 26 terms in total. You could find sum of 26 terms of that. That could be another idea, although I think that's prone to errors, because a lot of, if you try that, one possible error would be that you would end up using 25 terms here instead of 26. In this case, it's 26 terms. But often when you're doing this in an exam, you end up making this careless error. Instead of using 26, you use 25 here. It's actually 26 terms. But that could be another possibility. You could try that. This is going to be quicker. Just subtract from the first 35 terms the sum of the first 9 terms. Okay. Now, one last thing that we need to know about arithmetic progressions. Sometimes you will see a case like this. You'll have an AP in which, let's say, you have 3 terms like this: x, 25, 32. And you're supposed to find the value of x. All right. So you have an arithmetic progression. You could do it just by inspection as well as just in your head as well. But a proper way of doing this in writing could be, you would say, this is the first term. Now, this is something that you have to use sometimes, so keep this in mind. This is the first term. This is the second term. This is the third term. Since it's an arithmetic progression, the difference between terms has to be constant. Now, difference could be found by subtracting the 2 terms, the first 2 terms like this, T2 minus T1. Difference could also be found by doing T3 minus T2. Okay. And what does that give you? That gives you 25 minus x, that equals 32 minus 25. And that will give you the value of x. When you have three consecutive terms like this, you can say the difference between every two consecutive terms has to be the same. So if you have any unknowns in those terms, you could just find that unknown like this, right? You would say 25 minus x, that equals 32 minus 25. In this case, you can find out the value of x. That turns out to be 18 in this case. Now, in this example, it looks pretty obvious. However, if it was something more complicated, if you had something like this, x, and then maybe x or 2x minus 3, and then some other number, in that case, using this idea is going to make things quite straightforward. So basically, this works in general. Whenever you have an arithmetic progression like this, for which you know three terms, A, B, and C, any three consecutive terms, what you can do is you can write down an equation that connects these three things like this. You can say B minus A, that should equal C minus B. This is an equation that you can always write when you have three consecutive terms like this. If you have T1, T2, T2, T1, T2, T2, T3 like this, you would say T2 minus T1 is equal to T3 minus T2. So that means B minus A equals C minus B. So keep this in mind. You will need to use this quite often in the questions that you do. All right. Any problem with this now? Any questions? Make sense to everyone?
Sir,
Yes.
sir, can we use the other formula to find the value of the first term?
You can do that as well. You can use the term formula. You can use Tn equals A plus n minus 1 times the difference. But using this is going to be more efficient in most cases. Okay?
Okay, sir.
All right, so that's all that you need to know about arithmetic progressions. Now let's move on to geometric progressions. Let's see what you do with geometric progressions. Let's talk about GP now. So in arithmetic progressions, we learned that the difference between terms has to be constant. What about geometric progressions now? Let's understand these. Okay, now geometric progressions basically have the ratio between terms constant. The ratio between consecutive terms, that is constant. So in arithmetic progressions, the difference was constant. In geometric progressions, the ratio between consecutive terms is constant. Let me write that down here. The ratio between consecutive terms is constant in geometric progressions. Now, let me give you an example. Let's say you've got something like this. You have 3, 6, 12, 24, 48. How do you connect these terms? What's the relation? What's the pattern that these terms are following? How do you get the next term? You're basically multiplying the previous term by a constant number. So in this case, how do you get the next term? You multiply it by 2. 6 to 12, you multiply by 2. 12 to 24, you multiply by 2. So you're basically multiplying by 2 to get the next term. 2 is basically the ratio between the terms. So this is 1:2. Again, 6 to 12, that's also 1:2. 12 to 24, that's also 1:2. So the ratio between consecutive terms, we could say 6 over 3, that's 2, 12 over 6 is 2, 24 over 12 is 2, 48 over 24 is 2. The ratio between consecutive terms, that is constant. This is what a geometric progression looks like. This is the second type of sequence that you have in your syllabus. In O-levels, you had many different types of sequences. Sometimes you had to figure it out on your own in the exam because it would be some sequence that you did not know about before, but looking at the pattern, you had to figure it out yourself. In A-levels, you only have 2 sequences. You can't have anything else apart from these. Either the difference is going to be constant or the ratio is going to be constant. There's no other possibility as far as sequences or this topic is concerned. Okay, so this is the other type of progression, the other type of sequence. Now, an arithmetic progression was described by 2 things. It was described by the first term and by the common difference. Now, what about geometric progression? It's also defined by a first term. So first term is also important in this case. However, instead of difference now, we've got something that's called the common ratio. The ratio between consecutive terms, we call that common ratio. And this is denoted by this letter R. So in order to describe a geometric progression, you need the first term and R, the ratio between terms. Okay. And now how do you find ratio between terms? In this case, ratio between terms is given by the next term divided by the previous term. So you take any 2 terms, and among those 2 terms, the one that's coming after, you divide that by the term that's coming before. So any 2 consecutive terms, for example, if you take these 2, the ratio would be 24 over 12. Okay, that's what the ratio is. So next term divided by the previous term. All right, that's how ratio is defined for geometric progressions. Now for a GP as well, you need to know the term formula, the sum formula. I'm going to write those 2 formulas here. So now you understand the terminology, what the nth term of a sequence is, what the sum of a sequence is, right? So you understand those terminologies now. I'm going to write down the formulas here directly. So the nth term formula for a GP that looks like this, it's A R raised to the power n minus 1, right? So if you had to find any specific term of a sequence, you could use this of a geometric sequence, you could use this formula for that. It's the nth term formula for a GP. Okay. And there's a sum formula for a GP as well. There's only one sum formula that we've got. In case of GP, in AP, we had 2 sum formulas. In GP, for sum to n terms, we only have 1 formula, and that looks like this: A into 1 minus R raised to the power n divided by 1 minus R. This is also given in the formula sheet. Both of these formulas are given. These are the formulas that we use for geometric progressions. Okay. Now let's take an example. Let's take that same example that we wrote above. In this example, the first term was 3 and the ratio was 2, right? So now let's say we have a geometric progression, and in that geometric progression, we know that the first term is 3 and the ratio is 2. Now, if you had to find a specific term of the sequence or the sum to a specific term of the sequence, how could you do that? How could you find those 2 things? If you had to find some the 20th term, let's say T20, how would you do that? The value of A is 3, so you have 3 into R is 2, raised to the power n minus 1. You want 20th term. The value of n is 20. So you say 20 minus 1, and that's going to give you the result. It's going to be a pretty large number in this case, 3 into 2 raised to the power 19. And that's giving me 1, 5, 7, 2, 8, 6, 4. That is the sum of the, that's the 20th term, sorry. Okay, that's the value of the 20th term. All right. Now, in this case, it's often helpful to remember kind of a pattern as well that helps do some questions a bit more quickly. So in this case, for instance, watch T1, the first term is always A. Watch T2, AR raised to the power 2 minus 1. So that's AR raised to power 1. What's T3? T3 would be AR squared. T4 would be AR cubed, and so on, right? So you could kind of remember this pattern as well. If you're looking for T4, the power of R is going to be 1 less than that. If you're looking for T2, the power of R is going to be 1 less than that. So this is what the pattern looks like. If you were looking for T75, for instance, you would say it's AR raised to power 74, okay? Or you can just use this formula. It's just something that helps writing down the nth term quicker sometimes without using the formula if you understand this pattern like this. But that's how the nth term formula for a GP is used. Now, what about the sum formula? Again, we could use the same GP. We have the first term as 3 and the ratio is 2. If you were looking for the sum of the first, let's say, 8 terms of the sequence, how would you find that? The value of A is 3, so you put 3 there. Then you have 1 minus R, which is 2, raised to the power n. N is 8, divided by 1 minus R, which is 2. 1 minus 2. That is what is going to give you the sum of the first 8 terms. Let's figure this out and see what that turns out to be. 3 into 1 minus 2 raised to the power 8. Now, when you're inputting the value of R here, be very careful to put the value of R inside brackets. In this case, it's not a problem because the ratio is positive, but sometimes the ratio is negative. In that case, you have to be very careful that that negative ratio is written inside brackets properly. So for instance, if the ratio was minus 0.5, you would say 1 minus 0.5 raised to the power n. So minus 0.5 has to be written inside brackets properly. Otherwise, your answer is not going to be correct. So with negative numbers in particular, you have to be very careful with your brackets. You can't skip any brackets, okay? In this case, it's the positive number, so it's not going to cause that many problems. Now, what's 2 raised to power 8? 2 raised to power 8 is 256. So we have 1 minus 256 inside. In the denominator, we got minus 1. And that's going to give you the result. 1 minus this, and then divided by minus 1, multiplied by 3. This is turning out to be 765. So the sum of the first 8 terms of this sequence is 765. Okay? This is how this formula is used. Make sense to everyone?
Yes, sir.
Okay. By the way, in the formula sheet, you'll see an exception written to this formula. And that is that R cannot be equal to 1. Why? Because if R was equal to 1, you would end up getting 0 in the denominator, and that will break this formula. That will become undefined. So you can't use the formula when the value of R is 1. When the value of R is 1, think about what the sequence is going to look like. If it starts from 5, for instance, R is 1, so you have to multiply by 1. It'll be 5, 5, 5, 5, 5. So it will not be like a proper GP. It will just be the same number repeating itself. You could call this an AP as well with difference 0, or you could call this a GP with ratio 1. So generally, you don't get such problems where the same number is repeated, because you could classify it as any sequence. You could call it a GP with ratio 1. You could call it an AP with difference 0. You could call it some other sequence as well, because it's just the same number repeating. Okay, so generally, we will not get cases like that. So that's why you've got this exception for this formula as well, because this formula does not work when ratio equals 1. That will give us 0 in the denominator, and that will be a problem. Okay. All right. So these are the two formulas that we've got for geometric progressions. Let's have a look at a few examples in this as well. So let's say we have a geometric progression that looks like this. GP equals 16, 8, 4, 2, 1, 0.5, and so on. Now it's a geometric progression. What's the first term of this GP? What's the first term of this GP?
16.
16, right? What's the ratio? 2?
1/2.
1/2. So remember, next term divided by the previous term. So in this case, we'll say 8/16. And that will give you 1/2. You could say this is 1/2, or you could say it's 0.5, however you want to write it. Since it's an exact number, 0.5. So it's okay to write it as decimals as well. If it was 1/3, for instance, then you would avoid using decimals because 1/3 cannot be written in exact form in decimals. So you'd leave it as a fraction. In this case, it's all right. So sometimes your ratio can also be less than 1. This is also a geometric progression. Okay. Now, in this case, if you had to find, for instance, sum of the first, I don't know, let's say 15 terms, how do you do that? Sum of the first 15 terms. A, remember the formula, A into 1 minus r raised to power n divided by 1 minus r. Just input values in this. A is 16 into 1 minus 0.5 raised to power 15 divided by 1 minus 0.5. And you can see what that turns out to be. Okay, so this is giving me 31.999. That's the sum of the first 15 terms of the sequence if we were looking for them. Make sense? Let me write down another sequence. Let's say you have a sequence that looks like this. You have a GP and it goes like this. 2 minus 6, 18 minus 54, 162, and so on. This is also a geometric progression. What's the first term of this GP? The first term is 2. What about the difference? You can see the difference is not the difference, the ratio. You can see the ratio is constant because you are multiplying by the same number to get the next term. What do you get? How do you get the next term? Which number do you multiply 2 by to get the next term? -3. Similarly here as well, -3. How do you find that? Just take any two consecutive terms, subtract from the next term, divide the next term by the previous term, and that will give you -6/2, and the ratio turns out to be -3 here. And then you could use this ratio to find the sum of the first n terms, the nth term formula, whatever you want to do, you can do that. So in this case, if you were looking for sum of the first, let's say 6 terms or 8 terms, and this is 10 terms of the sequence, what would that be? A into 1 minus r raised to power n. So remember what the formula is. A into 1 minus r raised to power n divided by 1 minus r. What's the value of A? The value of A is 2. 1 minus r raised to power n. Now you've got to be very careful. Ratio is negative. You've got to put that inside brackets. 1 minus r is -3 raised to power 10 divided by 1 minus -3. This is what it's going to look like. And now you can evaluate this and see what this turns out to be. So this gives me 1 minus -3 raised to power 10. That's -59048 in the numerator. In the denominator, we've got 4. And this turns out to be -29524. This is the sum. This is the sum of the first 10 terms of the sequence. This is how you would evaluate this. Make sense? Any questions on this?
No, sir.
Sir, we keep the sum as negative when we write the answer.
Okay, I'm sorry, I missed you in the middle. Can you please repeat that? Lost in the middle.
We keep the sum as negative when we write the answer.
Yes. Why not? It's a negative sum, so it will remain negative. So if you
Okay,
had, for
sir.
instance, if you had a sequence like this, for instance, if you had -8, -16, -32, -64, all of these terms are negative. If you were to find their sum, the sum would also turn out to be negative. And that's perfectly okay. In this case, the sum is turning out to be negative because we have some terms positive, some negative. It's still a GP. What we're looking for is the sum of the first 10 terms. Now you see the first term is positive, sign is negative, then you have positive, then negative, then positive, then negative. And you can see the numbers are increasing. The numbers are increasing. In terms of magnitude, they're increasing. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. The 10th term is also negative. And 10th term is going to be the largest in terms of magnitude, and it's a negative number. And because of that, the overall sum is going to turn out to be negative. If you were finding S9 in this case, or S11 in this case, you would see they will turn out to be positive. So it depends on what the last number is in this case, because the last number is the biggest, that makes the sum positive or negative. Okay. So sum can, in fact, turn out to be negative sometimes as well. In this case, it does. Okay, let me write down another sequence here now. So let's say you have a geometric progression, and that looks like this. You have -3, -12, -48, -144, and so on. Is this a GP? Does this satisfy the condition for being a
Yes.
GP?
Yes.
Yes, the first term is -3. What about the ratio?
The ratio is 4.
Ratio is 4. Ratio is not negative here. The ratio is positive. When the ratio is negative, the sign are going to be alternating like this: positive, negative, positive, negative, positive, negative, because the minus sign is going to keep changing the sign, right? Here, the sign is not changing. It started from a negative number. It remains negative. The ratio is positive. You can try that like this as well. -12 over -3. What does that turn out to be? That's 4. That's a positive number. The ratio is positive. If you were looking for the nth term formula for this, nth term formula, can you find that? Remember what the nth term formula is? A(r) raised to the power n minus 1. For this particular sequence, what would the nth term formula look like? A is -3, so that's -3 into r. R is 4 raised to the power n minus 1. This is what the nth term formula for this GP looks like. So sometimes you may have to write down the nth term formula for a sequence as well. This is how you would do that. N will remain there as it is, and you will just input the values of A and R like this. And that's the nth term formula. Is that okay?
Yes, sir.
Okay, now let's have a look at another scenario that comes sometimes, and that is related to percentage increase and percentage decrease. So you'll find in the worksheet a lot of questions in which you have some kind of scenario given, some real world scenario given, and you'll have to convert that to a sequence problem. And this is something that happens a lot. then in this scenario that's given, you have a number that is increasing by a certain percentage or decreasing by a certain percentage. We need to understand how to convert that to a GP. So whenever there's a percentage increase or a percentage decrease to a number, it's always a GP. It's always a geometric progression. It can never be an AP. If something is increasing by a certain percentage every single time or decreasing by a certain percentage, it's always a GP. And how do you find the ratio of that GP? Let's say if something is increasing by 5%. So they say there is some value that is increasing by 5%. There's a 5% increase in that value every single time. Now you could think of it like this. One possibility is you could say, if the number was 100 first time, okay? Since you're talking about percentage, it's often helpful to think of it in terms of hundreds, because then you can say, okay, if you're starting from 100, if you increase it by 5%, what does that become? 105, right? And then you can say, okay, just divide these two numbers, 105 divided by 100, and that's going to give you 1.05. That's going to be the ratio in this case. So when you have a 5% increase, what's the ratio? The ratio is going to be 1.05. One way to figure that out, you write down numbers like this. You say, if the first number was 100, after 5% increase, the number would become 105. So it becomes 105 divided by 100. The ratio is supposed to be 1.05. Or you could also think of it this way. That you're starting from 100%. The original value, you can say that's 100%. If you increase that value by 5%, where does that go? After 5% increase, it becomes 105%. Now, how do you write percentage values in decimals? Can you write 105% in decimals? What would that value be? 1.05. And that's what the ratio is going to be, 1.05. So whenever you have a percentage increase or a percentage decrease, you can write that as a GP, and you can write down the ratio of that like this. If you had, for instance, a 20% increase in something, what about this? What would the ratio be in this case? Again, you could think of it like this. You could say you had 100% originally. After 20% increase, where does that go? That goes to 120%. How do you write 120% in decimals? That's 1.2. So the ratio in this case is going to be 1.2. So if something is increasing by 20%, you would understand that it's a GP with ratio 1.2. Similarly, you could have decrease as well. If you had, for instance, 7% decrease in something. If something was decreasing by 7% every single time, how do you think about this? Again, start from 100%. From 100%, if you decrease 7%, what do you get? 93%. Can you write 93% in decimals? That will be 0.93. So the ratio in this case turns out to be 0.93. So it's a GP with ratio 0.93. So percentage increase or percentage decrease, you need to remember it's always a geometric progression. And this is how we find out the ratio for that. Is that all right? Any questions on this?
Sir,
Yes.
sir, will it be given in question that the progression is arithmetic or geometric? Or do we have to figure it out?
No, you'll have to figure it out in this case. So when they will just tell you it's increasing by this percentage or decreasing by this percentage. So when you have problems in which when you have word problems in which they give you a scenario, a real world scenario, and you have to figure something out there. In most cases, they will not tell you it's an AP or a GP. You'll have to figure it out yourself. If something is changing by a constant number every time, that will mean it's an arithmetic progression. If something is changing by the same percentage every time, that will be a GP. Okay. So you will sometimes have to figure it out yourself in cases like this. Make sense?
Okay, sir.
Okay, one last thing before we end. We will not be able to do sum to infinity thing today. We'll have a short class tomorrow in which we will do sum to infinity. Does that work for those of you in the Middle East? Your Eid is on Wednesday, right?
Yes, sir.
Can we have a class tomorrow? Maybe a short one, 40 minutes or something?
Sure, sir.
Azam?
Yes, sir, I don't actually mind.
Okay. Right, works for you as well. I think we also not in Pakistan. Okay, all right. So we'll have a short class tomorrow to discuss sum to infinity. And then you can attempt all the questions from the worksheet. After that, we're done with it in terms of concepts. But then if you have problems, we will discuss them after the Eid break. Now, one last thing for today. Let's say you have a GP like this. It starts from 5. And then you have one term missing. And then you have 320. And what you want to find out is the value of x. What's the value of x in this GP? Now, again, one possibility is to use the term formulas that we know about. But in these cases, it's much quicker to use this idea that since it's a geometric progression, the ratio of consecutive terms is supposed to be constant. So if this is T1, this is T2, and this is T3, we know that the ratio between consecutive terms is supposed to be constant. Next term divided with the previous term, it has to give you the same number every single time. So ratio could be calculated like this, T2 over T1, or it could also be calculated as T3 minus T3 over T2, which means we've got x over 5, that equals 320 over x. And that gives you an equation. You can solve this equation to figure out the value of x. X turns out to be, so in this case, x squared equals 320 into 5. That's going to give you 1600. We take square root of this. X equals plus minus 40. So x could be 40 or it could be minus 40. Both the possibilities are there. These are the possible values of x that you get from this. Okay. So if it was 40, the ratio would be 8. If it was minus 40, the ratio would be negative 8. So both values of x are possible. Okay. So when you have 3 consecutive terms in a GP, this is how you can connect them. And this is very helpful in some questions. Instead of using the term formula, it's going to make your life easier if you just use this. If you have 3 consecutive terms like this, A, B, and C, you can say B over A is supposed to be the same as C over B. B over A is supposed to be equal to C over B. This is an equation that you can make from this directly. Okay. So now you should be able to attempt a lot of questions from the worksheet already. I'll be uploading the worksheet right now. You can start working on some of those questions. And then tomorrow, we will do sum to infinity. And after that, you should be able to complete the worksheet as well. All right, so that's it for today. If you have any quick questions, let me know. Otherwise, we're going to end with this here. Any questions, anyone? Any problems?
Sir, for the percentage increase or decrease, do we write A as 1.0?
No, no,
Zero,
A will be given. You'll have some value of A there. You can only
okay.
find ratio. You'll have A given there. You will know where the sequence is starting from. Otherwise, you can't do it. We can only find the ratio using percentage increase or decrease, not the first term. That will be given. Okay, anything else?
No, sir.
No? Okay, so I've uploaded the worksheet as well now. You can start working on that. Apart from the questions that involve sum to infinity, you should be able to do the rest of them. And tomorrow, we will do that last concept as well. All right, so that's it for today. I'll see you again tomorrow. Allah Hafiz.
Sir,
Yes.
sir, are these questions combined in questions?
Yes. Yes. So in some questions, you could have one part that relates to arithmetic progression and another part that relates to geometric progression. So yes, that's possible.
Okay, sir. Thank you.
Okay. And it also comes with some other topics. Sometimes you'll have you'll see some questions in which they involve circular measure. Then sometimes you'll have to solve quadratic equations as well. And you'll find, I think, a couple of questions in paper 3 for this as well, in which you have to use the concepts of sequences. So yes, it does come with other topics as well. Okay. All right. So that's it. I'll see you again tomorrow. Allah Hafiz.